be a very informal and fun session. So the overall idea is to just make you aware of the fact that what exactly we have seen in last 6 days, right? So as you probably have heard my name lots of times, but I'm Aadirupa. I'm a PhD student here. And our other two organizers, Abhirup, he's also a PhD student here, and Arvind, will jointly talk about that what exactly we have seen in last 6 days and what is actually the takeaway message, right? So even during the lunch session yesterday, some of us actually came to me and asked me, even some of our faculties suggested that it might be good to have a broad picture or kind of a route map session that how these talks are structured, because right now we have seen like almost 50 plus talks and like lots of topics are thrown at you, but you are probably wondering that how these topics are interrelated, or like what are the fundamental subjects, what are the basic subfields, like how they're interconnected, how to connect the dots, right? So it might be it might be good to give you a high level, like a big picture of what is computer science. Okay. Seems like the pointer is not working also. Okay, so we're all here because we all have a common interest, right? We are all interested in computer science. We all agree to that. But here comes the difficult part, okay? So we have too many subjects. We have came across so many different topics, and some of this are covered in the summer school, some of them are even not covered, okay? But it looks confusing, okay? What's going on here? So you people might be thinking, like, is there a good roadmap that we can see, like these are the main fundamental subjects which we need to learn to excel ourselves and to tell like we are good computer scientists? What are the good roadmap for that? Okay, so I think in last 6 days you have came across this 3 major divisions of computer science. So you guys need to tell me what are the 3 major divisions of computer science, Professor. Okay, first, what is the first thing? Theoretical computer science, okay. Systems, and I'm shocked that the artificial intelligence or the intelligence systems came at the end, because when we were going through the applicants, okay, 95% of them were like artificial intelligence and machine learning. So so you guys mentioned it at the end, but yeah, you guys are right. So it's intelligence systems, it's theoretical computer science, and it's computer systems, okay? And unfortunately or fortunately happens to be the case that I belong to intelligence system. Like I'm doing my PhD in machine learning. Our other organizer, Arvind, he will give his, he will do his own gong show for the computer system part. And our Abhirup will talk about theoretical computer science. So I'll start with intelligence systems. What is the high-level abstraction of intelligence systems field of research? So what we do is basically we deal with data, okay? We basically play around with chunk of data and we intelligently try to learn some model out of it, okay? With whatever purpose we have in our mind. Maybe it's for some forecasting job, for some prediction, to design some mechanism, for something like that, we learn from the data. So more specifically, we have chunk of data, we have some intelligent algorithm, and we come up with a prediction model. And keeping in mind whatever the performance measure we have in our mind, we want to optimize our performance measure in terms of it, okay? So this is what is intelligence system. And if you, okay, so this slide looks a bit cumbersome. We actually had animated it, but it's not working. So since we had difficulties in playing it from Google Drive, just deal with it, okay? So I'll go one by one. So first thing is, okay. So I think the first thing is definitely machine learning. Okay, so this is what is happening. So these are like the major subfields of computers, major subfields of intelligence systems, okay? So the first thing is machine learning. Well, you remember the first talk on Monday, right? Sanim and Sachin gave a very nice demo talk on introduction to machine learning. So, and even later on, Srijit talked about this artificial intelligence things, okay? So machine learning is what comes under intelligence systems, and then it's like the big data. If you have a big chunk of data, how to make it scalable, where to store it, how to, scalable systems, kind of talk that Professor Yogesh Simhan talked about. Professor Talukdar might also have talked about a little bit. Okay. And then comes the natural language processing, which basically says like, how to train your computer to talk in terms of human language, to be in a very broad way, to teach a computer how to talk in terms of human language. And Professor Talukdar gave a talk on Monday, and later on Prakhar and Chandrahas gave a very nice demo yesterday, if you can remember. Prakhar also talked about the knowledge graph inference, where we have encountered questions like, if you remember, it was a very nice, and I find it very interesting that when Sachin Tendulkar got married, who was actually the US president, and we can actually infer those kind of informations from Google using this knowledge-based graphs, right? So these are very interesting topics. Okay, and then comes this deep learning, where Gaurav Pandey gave a very nice demo talk also yesterday. I think yesterday he talked about deep learning, where we have this, where we get high-level abstraction of data using multiple layers, multiple processing layers. I'm never claiming that these are like the independent subjects, okay? I'm never claiming that these are all mutually exclusive and there is no overlap, okay? What I'm claiming is this is like the broad level, this is like the different domains of research under intelligence systems, but they are highly interlinked. And there comes, from there onwards, this has a very significant overlap with the theoretical computer science, okay? Especially from online learning onwards. Online learning, Professor Aditya Gopalan, if you remember his talk, he talked about the sequential bit prediction thing, okay? That is like the preliminary, like the first problem we encounter in online learning. So when you have data streams, coming in, okay? You don't have the data altogether, the batch data, but it's coming one by one. And how can you do an intelligent learning from those kind of data? So that is basically online learning. And there's a whole dedicated bunch of literature for this thing, online learning. Then comes this reinforcement learning, which is kind of even more even more sophisticated version of it, when you not only learn from changing, you actually learn from changing environment. You not only see the data, but you want to learn your prediction model depending on which environment you are in. So it's even a generalization of online learning kind of thing you can think of. Then Sindhu talked about it. I think on Tuesday she talked about it. And then comes this game theory and mechanism design, which has a significant overlap with theoretical computer science. So these are like the interdisciplinary subjects, okay? I think Aadirupa will also mention about the subjects in his talk. And then there are several other topics. If you feel like this is a very complicated, this is a huge set, let me assure you, there are many other subjects which we couldn't cover, okay? We tried to make the talks a little more heavier in the intelligence system size, because we thought like lot of you are actually interested in artificial intelligence, machine learning, but still we couldn't cover a lot of things like bioinformatics, graphical models, pattern recognition, data mining, lots of things we couldn't cover, okay? But it's not like they're mutually exclusive. There are some connections, but there are different topics like this. And okay, so now you might be wondering that, yeah, these are the high-level topics, these are the areas of research, but what are the fundamental subjects we should study to build our, get our intuitions correct, to pursue our research in this field? So it's definitely probability statistics, which Professor Manjunath has talked about. And then there comes linear algebra, which again Professor Manjunath talked about. And these are like the fundamental subjects for any areas of research in computer science, okay? And then comes the optimization technique, which is very important for machine learning or in general for intelligence system research. And then data structure algorithm is, of course, it's essential for, computer scientists must be aware of algorithms, right? You cannot do anything if you are not, if you don't know data structure algorithms. It's for like the essential tool for every field of research in computer science. So yeah, so that is it. And next, Aadirupa will talk on theoretical computer science, the divisions of theoretical computer science.
Okay, so I think all of you actually attended most of the talks, so I'm not repeating their names, so you know all of this. And but theoretical computer science, okay, currently in a kind of say, I mean, maybe actually moving towards from the discrete domain to the continuous domain, trying to give answer to many of the problem in the where the domain is actually continuous, can take all the reals as an input. So probably we'll see a lot of changes in next couple of years. So few of you actually asked me yesterday about the, I mean, they are interested to join machine learning as a, I mean, as a researcher in that. But I'm just telling you one thing. So maybe when you people will join, maybe it will be another 2 to 3 years. Maybe within that time, people started exploring the say the theoretical aspect of machine learning. I mean, that those problems will be more interesting than the whatever people are doing. People are now designing algorithm, designing things, but people started exploring that what is the, I mean, kind of bottleneck or what actually, how far we can go. So things are moving. I mean, probably that time the theoretical computer science will contain many of the topics which actually now in the previous slide. So it's not a very rigid boundary, but things will move. So these are most of the sketch, and like you have to learn probability statistics, and better to learn probability really well, because in coming days we have to use probability in everywhere in computer science, because randomized things are taking charge. So okay, and with that actually I'll ask Arvind, okay, please come and take over that system thing.
So, yeah, I'll be talking on computer systems. Not much. Most of you are not interested, anyways. But just to say that, it's maybe who wants to train their neural nets faster? Who wants to train their neural nets faster? Who wants their machine learning algorithms to run faster? You don't want your algorithm to run for 3 weeks and then say, okay, I have crashed somewhere. So you don't want any of those surprises. So do you remember do you know what this is? Yeah, it's the Sahasrara supercomputer at CSAUSS. So what kind of work you can do on a supercomputer? One, you have architecture, right? You'll have to design this, and you'll have many applications which use oh, sorry. So it's so you have high performance computing, in the sense you have some compute applications which run some computing applications which actually need to run very faster. Otherwise, as I said, you don't want your applications to run for a very long time and then say, okay, fine, the results are not good. Then you have compilers, and again graphics. You have lots of images from these satellites and everything, and you have images from medical imaging, all these things where you have significant data, but you need faster algorithms to compute it. And you have databases. I cannot say anything more. As our chairman says, it's the backbone of computer science, or something like that. So then we have operating systems, distributed systems. You need to find an efficient way to use this huge distributed cluster in a profitable fashion. So these are a few things, and there are other aspects as well. So do you remember what this picture is? Do you know what this is? Sorry? No? Sorry? Okay, it's a rocket explosion, Ariane 5 rocket explosion picture. So this was one of the first few rockets that was launched by NASA. And do you know what the problem was? Why the rocket exploded? Correct. It was basically an integer overflow. So any small mistakes like this can have catastrophic consequences. So in those few areas, we have software engineering, and we have again compiler support, where compilers can generate verified code, and you have automated verification, where you have a specification and a set of properties, and you say whether the program that you build satisfies the properties or not, and you have program analysis as well. So this is a brief overview of what all systems research is done at IISc. I'm not going beyond IISc at this point. So we had a few talks. One was by Professor Govind Rajan on architecture, Professor Halsa and Srinivas Karthik on database systems. We had a talk on computer graphics as well. And these two, I would club them together, saying program analysis and verification and software engineering. Yeah. Program analysis and verification and the software engineering together as a single group. And we had high performance computing by Dr. Yogesh Simon. And there were a few things like operating systems and compiler design which we couldn't cover. But okay, what are the prerequisites? So if you are an aspirant for a systems PhD or a master's at IISc, what are the prerequisites? So if I tell discrete math, you'll all scold me because how are they related? But believe me, there is no compiler without discrete math. Okay, and then even graph theory as well. Data structures, algorithms, it's the fundamentals of computer science. And linear algebra. You'll be surprised how these things are related, but if you want to explore this, come to systems course at IISc. So finally, this was the set of things that you had, the wide variety of areas. So the ones in red are your intelligent systems. The ones in yellow are theory, and the ones in green are in systems. The ones in blue are intelligent systems, and the ones in pink are interdisciplinary, where there are many things that are common. So finally, you would be able to figure out which stream falls in, which subject falls in which stream of computer science, I hope. If not, again, you know whom to bug. And finally, thanks to our sponsors, Xerox Labs, Microsoft Research, Google, and the Department of CSA, without which we couldn't have had this summer school. And behind the scenes, there has been a lot of work done, especially by the chairman and the divisional chair, Professor Halitsa and Professor Narhari. All the faculty of the department were also very happy in encouraging us to conduct this summer school, and they have given their valuable feedback. The CSA office has been extremely busy over the days with all the paperwork and everything, so thanks to the entire CSA office. Technical support for Ashrata ma'am and Shankar sir, so they have helped us in recording the talks, and it will be available for you guys online if you want to go back to it. And all the non-technical staff of CSA, the hostel office for providing the accommodation, and the Jawahar Visitors House. And there are a lot of volunteers as well, Sridhar and Ruby, whom I should mention in this, who helped us in setting up the website as well as in taking care of the accommodation. And last, one person whom I should mention who took up the initiative for this, Aadirupa Saha. We were sitting like morons doing some nonsense work while she was the one who came up and said, okay, we'll do this. So thanks to her. So that's it. Thanks a lot.